Okay, good morning, DLs. Welcome to Sports Day, or what's the other word? Mathetics Day? Mathletes or athletes? Okay, let's have a word of prayer and let's get started. Father, thank you for today. We thank you for everything, the sunshine, just the rest that we received last night, chance to be up today, a life to live. Pray to be with the boys as they are um, probably still traveling, but yet reaching their destination, going to the tournament. Pray to just help them today, Father, that they will be able to victories and come back with the W's for their. All safe here. Help us all to have a good day, and just help us to keep in mind the things that we're doing, whether they're right or wrong, and change if we need to. Bless us in thy precious name. Amen. Okay, this is where we are at, making companions of the wicked. Uh, it it should have corrected its dead yesterday, but it should have replaced or corrected itself. Huh? No, it corrects itself. Okay. Proverbs 29:24. Whoso is partner with the thief hateth his own soul. He heareth cursing and bewaileth it not. Okay, these are verses that relate to making companions with wicked. So of we've gone to the point of mere friendship. Okay, it comes to a point at this. It comes to a head at this point that the the wicked, or whoever we are doing this to, um, joining companionship with, they start expecting things to happen. They start expecting you to do things for them. Okay? And if you come in whatever manner. So we're now in misdeeds. Okay? Because it's expected of us to do it because we're part of them now. We're not only, we also do what they do. Whether we choose, well, choose to affect lead to a people. Okay. There's two lessons. The law or accomplice. Um, if you're sitting in the car waiting for the thieves to come out of the bank, you're going to be held just as liable. And if there's a murder in the bank, you're going to be held accountable too. You may years because you didn't pull the trigger and kill the person, but you were part of see wrongdoings, refuse to as guilty as the deed as yourself. Okay? Now it goes right along with the aspect of being in the car. I didn't steal. Well, you were still part of it. Okay? Huh? No, I felt dead at the time. No, thank you. Um, so watch what you're doing. You're companions with them. They're expecting you to do it. By the way, DLs, Giselle, Adam, Yuvia, and Lacey, good to see you. We're still waiting on, but that might come. But anyway, make your choices and make the good choices. Your own words. Proverbs 1. In your words, in your own words, write down what you think the meaning of the verse is. Give me some feedback at this point. I have something you can write down, but think. Basically, consent on that. What do you? Okay. Someone tempts you to do something or wants you to do something. Good. Anybody else? Shh. Here's what, sir. Okay. When sinners invite you to join them, just say no. He just said, no, let's do the opposite. Okay? In the long run. You may feel that you are letting someone down, okay? Because they are a friend. And we talked about friendship yesterday. They are a friend, okay? You may feel down because you've said no. Don't feel bad. Here's a slippery and put you. Okay? You stumble. Anybody ever fallen down any stairs? Okay. I I I remember when I was in the youth group, we had what they called sing and sips, where we'd go after church on Sunday nights, somebody's house, and we'd have in together. They had us down in the basement. Shh. And so I had a plate of food, drink in my hand, and my shoe heel or whatever, and down I went. I put on and food, drink everywhere. But so I've had my experiences, but I didn't break a bone, so that was good. I broke a wall, not a. No, they were. Huh? Would you like to come up here again? Shh, girls, please. Girls. Your only hope, in this case, this stairway, is to get away from this temptation as quickly as you can. Okay? Those home video type things where they have it's all ice on the steps and people are walking out and they go what they needed to do was okay, instead of over the slippery ice, they need that. How it's in a heart. Walk with the wise. Develop relationships with the ungodly. That should be a capital. Of the ungodly. Reprove of take each of these steps. And look where it starts. It starts with a okay attitude. That attitude is going to be focused upon God. Okay? Yeah. Purposefully did that. I was thinking. Yeah. Okay. Visual learners. You know, see, so now you see the steps. Okay. And what I should have done to walk. I couldn't get down that low. Huh? Okay. Spiritual victory. If you can avoid the wicked, okay, go another route. Maybe in your eyes that other route's going to be harder to go, okay? But it's going to take you away from the temptations. It's going to from the wicked. By the way, good to see you, Jeremiah. We've missed you, okay? First part of the class. So, welcome to class. Good to see you. Oh, here we are. My lesson. The importance of attitude. What's the definition of attitude? Attitude is the direction one is pointing. Your attitude shows a lot of where you want to go, of where you want to do, what you want to do, who you want to be with, your direction. Posture, tendency is part of your attitude. Okay? Okay, some people, they, you're talking to them, and they will sit there. Yeah, I'm listening. Yeah, okay. Understand. Okay. It's your posture, your inclination. Your tendencies will show your direction, will show what kind of attitude you have. Everybody done with that? Everybody done with that? Every success or failure begins with an attitude. I always told the teams that I coached, when you start the game, or even before the game, Your attitude towards the game is how you and how the team is going to play. And if you have a rotten attitude before the game, that is going to portray in the game. You're probably going to foul out. You're not going to be supportive of the team. The team is going to look bad. The team is going to get upset with you, or your attitude is going to filter onto everybody else. Okay? Every success or every failure starts with what kind of attitude you're going to have. Focusing on God strong state. Mind is stayed on thee because he Philippians 3:18 and 19 says, "For many walk with whom I have told you often, and now tell you even weeping that they are the enemies of his destruction. Their belly is in their shame, mind earthly things." If your attitude is bad, expect destruction to come in some form. Okay? Can't tell you exactly. It'd be kind of nice to know exactly what that destruction would be, so that maybe we could gear our thoughts to, well, if we knew what the destruction was going to be, okay, we would choose either A, to have a different destruction, B, to have a different one, C, to have a different one, and to avoid the main destruction. And yet, what's the choices that we're making? Are they still for destruction results? Or is A, B, C, D, E, whatever letters you want to put in there, is any of those towards a proper attitude to God? Okay? You would have a choice. Decisions. Every success or failure begins with attitude. Helps you to make the right choices. There's two dangers. Envy. Proverbs 3:31 and 32 says, "Envy and for the forward is an abomination to the Lord, but his secret is with the righteous." We always have a tendency to do it because it's fun. It seems like a lot of times that the wicked get away with more, and you can't understand why. So you want to join them to get away with things, and yet back to because of at the end. In envy, our old nature are having fun. It says it. Thought that? I have in the years. If you've ever thought that, you just need to keep in mind that's my nature. That's my old nature. That's not me. We've turned. Shh. We're taking the glory away from God on ourselves. Is be not thou envious against evil men, neither desire to be with them. And then the desire. Okay? Envying because they're not getting into trouble, etc., etc. And so my desire is to do what they're doing. Attitudes. This is the end. The end doesn't have to be destruction. Excuse me, but there is an end. Consider the end of the wicked. Happen. But a lot of times we just think of the present because now it looks fun. It seems fun. It is fun. But we're not thinking about what's going to happen. Psalm 73, 17 and 19 says, until into the sanctuary of God, then understood I their end. Surely thou didst set them in slippery places. Thou cast, how do you say that word? The castest? This word. How are they brought into desolation? As in a moment they are utterly consumed with tears. Consider what's going to happen. Okay? That's always hard to do because we get caught up in the moment. Continual companion of God. This is your victory. This is how you get victory over this. By the way, with letter A, consider the end. When you're considering the end, you need to ask God to help you to avoid that path. Okay? To avoid that end of destruction. Psalm 73:23, nevertheless I am continually with thee, me by my right hand. Be a companion of God. Third, fear. Proverbs 23:17. But be thou in the fear of the Lord all the day long. Don't, girls, don't wait until you get caught in the snare. Ask God to help you avoid Satan's web. Okay? Before you get there. Okay? If you can trust in God, ask Him for the strength, you are going. Okay? I didn't think we would, but I would have given you quiz 6. Since I'm on Wednesday, it'll be due on Friday. Okay? You have a verse quiz on Friday, Proverbs 16:32. Proverbs 16. So I will send this worksheet to you, Yells, and I'll hand it out to class here tomorrow. Again, due Friday, and this also. Well, they're not, but since you're not going to be here on Friday, try and get it on Thursday. Okay? The worksheet. Okay? Try to get it on Thursday so that you don't have to worry about it for Friday. Okay? Okay, so watch your paths. May they be for the Lord. We'll see you later.
Okay, page 142. Let's work on diagramming numbers, was it 8, 9, and 10? 8, 9, and 10. For those of you in distant learning, we need to please turn in your diagrams from yesterday as well as your vocab from yesterday. And then we are on page 142 in our grammar books. Okay, so number is 8, 9, and 10. Last night you should have done 5, 6, and 7. But let's look at number 8, okay? So what do I bracket off within this sentence? Whatsoever ye have spoken in darkness shall be heard in the light. Okay, Austin, what would you bracket off in this sentence? In darkness is also part of that bracket, but good. Whatsoever ye have spoken in darkness, that's all in one bracket. Okay, so let's find our subject and our verb. Let's first find our verb in the independent clause. So the clause that can stand on its own, also known as the sentence. Okay, so what's our verb? Andrew? Shall be heard. Good. Shall be heard is my verb. I would underline that twice. Who or what shall be heard? What's my subject here, Maya? Not light. Okay. One thing to point out, remember, Maya? What was it? Okay, but light is in a prepositional phrase, so we know that that word itself can't be the subject, okay? So make sure you're watching for those. Sophia, do you know the subject? Not just ye have spoken. Whatsoever ye have spoken, remember, in darkness as well, okay? That entire dependent clause is my subject, okay? So whatsoever ye have spoken in darkness shall be heard, okay? So how would I diagram this? Okay, you want to come up and show us? All right, then someone else wants to come up and show us? Okay, Amethyst, come up and show us. Sure. Okay, so everyone should be either diagramming this in their book where you can find some room or on a sheet of paper with us. Probably find some room in your book to diagram it on the same paper. If you don't want to, that's fine. Paper, a sheet of paper is fine. Remember, in review what we said last week, what indicator words are always going to go on floaters? Does anybody remember? Andrew? That, whether, and if. Okay, also understood X's for the word that. Okay, good.
Sweaters are hard to wear, man. Laughing. I already explained this to you why you turn the camera.
Okay, I'll turn it after you go sit down, all right?
What color is this?
Yes. I'm just watching.
Quiet, guys. You need to help out here and not quiet.
It's like,
No.
no, it's like a,
Okay. Is this really bad?
okay, is that your final answer?
No. Yes?
Okay, so let me move the camera now. Okay, not bad. It's okay. Ooh. All right. Okay, so look at this. Look at your clause, okay? Whatsoever ye have spoken, okay? So, whatsoever in this sentence actually functions as something within the clause, okay? We just said the words that, whether, and if are the only words that go on the floater line because they're not actually part of the clause. Okay, so this one, whatsoever, is actually functioning as a DO. Okay, it's saying ye have spoken whatsoever. So my whatsoever is going to be in the direct object spot, but everything else is correct, okay? Ye have spoken whatsoever is my subject, or whatsoever ye have spoken in the light. You didn't have to diagram the prepositional phrase, but good, you did. Okay, shall be heard, and then in darkness. Actually, this would go underneath here, but because it's spoken in the light. Oh, then in darkness goes underneath there. Sorry, my bad. Okay, but you're right. So that goes underneath in the light. I thought it says whatsoever he has spoken in the light. But yes, never mind. Okay, so forget about the prepositional phrase. But yes, so whatsoever is functioning as a direct object in this sentence. What's your question? Oh, yeah. Uh-huh. But it's not, it's that, whether, and if goes above it. That, whether, and if, not what. Okay? That, whether, and if. Okay? All right, number 9. Tom knew nothing about Abraham Lincoln except that he was born in a log cabin. So what do I bracket off in this sentence? Okay, who can raise their hand and tell me? Avery. That he was born in a log cabin. Good. So I would bracket off that dependent clause. Okay? So let's find our subject and our verb within the entire sentence. Okay? What's my verb in this sentence? Gabby? Knew. Okay? Who or what knew? What's my subject, Lena? Tom knew. What did he know? Nothing. Okay? Nothing is my DO. Okay? About Abraham Lincoln, what do we call that phrase, class? A prepositional phrase. Now, what is except that he was born in a log cabin? How do we label this? Good. Okay, it is a prepositional phrase. Here's why. Except is my preposition. We know that prepositional phrases need objects, so therefore, that he was born in a log cabin is functioning as my OP. Okay? So how would I diagram a noun clause in the object of the prepositional phrase? Spot. Andrew, you want to come up and show us? Just watch the chord right here. You don't have to, but you can just do it since you know what it is. Yes. Above. Because if doesn't describe anything, whether doesn't really describe anything, and that doesn't really describe anything. Thank you. You can just do it all the way up top. Good. Awesome. Okay, so this is your diagram. Okay? Tom is your subject, knew is your verb, nothing is your direct object. Good. So, that he was born in a log cabin is my clause here. Obviously, if you have room, do it all the way down so that it doesn't go through, but that's fine. It just know that it hovers above the clause, okay? The words that, whether, and if will go on a dotted line hovering above your noun clause. Except is my preposition, goes in the prepositional spot. So good, Andrew. Excellent job. Number 10, Mr. Harvard asked when Jerry's report would be finished. Okay? Mr. Harvard asked when Jerry's report would be finished. What would I bracket off here? Elijah? When Jerry's report would be finished. Awesome. Okay? Now, let's find our subject and our verb within the sentence. What's my verb here? Jaden? Asked. Who or what asked? Jesse, what's my subject? Mr. Harvard asked. So, when Jerry's report would be finished, what is this functioning as? You can raise your hand and tell me. Gabby? It is a DO. It's answering who or what. What did he ask? When Jerry's report would be finished. So, now that we know what it is, how do we diagram this? Sophia, you want to try it? No? Okay.
So how would those be?
Mm-hmm.
To the word.
Mm-hmm.
Sorry.
Okay. Gabby? Oh. Yep. Oh, let me move this up for you. Sorry. Oh my goodness. Mr. Hayward.
Actually, the original name and the A is a vowel sound instead of a long.
Havard.
No sound. It's kind of a long sound.
Mr. Habad.
Far back.
Mr. H.
No, Gabby was like, have our far back. Dot, dot, dot.
Final answer?
Wait, so I'm gonna say no. Wrong. Everything.
That's why I say it.
Yeah,
Okay. Thank you, Gabby. The only two exceptions here would be, well, actually three. Okay, one, spell the last name right. Two, with diagramming, you want to put, I mean, I guess it's not that big of a deal to me, but I mean, like it has you diagram it underneath the verb. Okay, and then also, when is an adverb describing when it would be finished. Okay, so when would go underneath the verb. All right. So Mr. Harvard asked when Jerry's report would be finished. Obviously, Jerry is an adjective describing report. So that's how you diagram number 10. Okay? Well, that's what I say. You can either diagram it on a sheet of paper or in your book. So, all right. Using parallel structural, we'll get into it tomorrow. Remember that you have tonight for homework, do 7 through 12 2 times. Let's go ahead and start review for our test So take out your literature books. So list 7, numbers 7 through 12, vocab and definitions twice. No grammar for tonight. Okay, literature, we do have a test on Thursday. I do have some candy, so if you want to raise your hand and answer correctly. Mrs. Coral versus everyone. At practice, she's always like, make it fair. Let's do you and me, Mrs. Coral, versus everyone else. I was like, how is that even fair? But she was saying the other teams weren't fair when we gave her some like another starter, and I was like, how is me playing with you fair? Anyway. All right. All right, so, I mean, the other team had the same exact one as you, but we'll just move on there. All right, some questions. What is the correspondence of sounds? Let's start with Elijah. Correspondence of sounds. The answer. What is correspondence of sounds? Correspondence of sounds. Last night you should have begun studying for your test on Thursday. Who knows? Austin? It is a rhyme. Awesome. Ready? Okay. What is the regular recurrence of sound? Gabby? Rhythm. What are using words which sound like what they mean? Using words which sound like what they mean. Avery? Automatopoeia. Well, that's why we're raising our hands. Okay, let me call on you. What is the repetition of the accented or stressed vowel sound in all succeeding sounds in which words come at the ends of the lines of poetry? And rhyme, good. Okay, I don't want to hit your computer. Okay, what is rhyme that occurs within the line? Within the line, what kind of rhyme happens? Within the line. Because, okay, do you know it? No. Internal rhyme. Within the line, it's internal rhyme. Okay. What is sound similarities that occur between words that are not true rhymes? Jesse, do you know? Sounds similarities that are not exactly rhymes. 6 and 7. Okay. Andrew, do you know? So they're not quite rhymes, but they are similar. Who knows? Anybody know? Okay, this one is approximate rhymes. Okay, approximate rhymes. So think of, obviously, approximately is not a definite answer. So approximate rhymes aren't definite rhymes. They're just sound similarities. Okay, what is the kind of rhyme where it's only one syllable of the word that rhymes? Gabby? Masculine rhyme. 2 or more syllable rhymes. Andrew? Feminine? Sorry. Okay. What is the use of initial consonants or vowel sounds that are the same, as in like tried and true? The use of initial consonant or vowel sounds. So the first letter is the same. Elijah? Alliteration. Good. Okay. What is the repetition of final consonant sounds? Okay, so like they come at the end of the word, like first and last. Maya, do you know? What was it? Not end rhyme. End rhyme comes at the ends of lines of poetry. This is the final consonant sound. Okay, consonant sound. Consonant is the key word. Class? Consonants. Okay, I couldn't choose which one. All right, consonants is the final consonant sound. Okay, what is the repetition of vowel sounds followed like unlike consonants? Unlike consonants, like mile, time, mind. Adrian? Austin? Sorry. So sorry. not assonance. Yes, assonance. You're good. You're right. What is the soft, smooth assonance? What is the soft, smooth, or pleasant sound in poetry? Jaden? Euphony. And then the rough, harsh, unpleasant sound. Avery? Cacophony. Okay. What is the occurrence of rhythm at regular intervals or a poem's established rhythm? Okay. Amethyst? A meter? Yes. I'm so sorry. Your hand was like, but it was like sound, hand. Anyway. Okay, what is the pattern in a line of poetry consisting of one accented syllable and one or two unaccented syllables? Austin? Yes, it is a foot. Awesome. Okay, what consists of, actually, we don't need to know that one. What is unrhymed iambic pentameter? Unrhymed iambic pentameter. Okay, blank verse, but since we were just yelling it out, you don't get a candy. What is when two words look as if they should rhyme, but they do not? Keyword is look. Were you raising your hand? You're like, okay, amethyst. I rhyme. Okay, so that one, oh, sorry. Okay, so with I rhyme, okay, look at this. They look as if they should rhyme, okay? So obviously eyes, they see. So look as if they should rhyme, okay? Maybe that one will help you. And then the construction of two or more thoughts in the same pattern. Gabby? Parallelism, okay? So with parallelism, you can remember this, two or more thoughts in the same pattern, okay? That means they're parallel with each other, okay? No, parallelism. Let's see. The next one, yes, is sentimentality. But make sure you know the definition of sentimentality, and that would be the indulgence of emotion for its own sake without regard for honestly presenting the truth of human experience. Okay, so that would be sentimentality. Okay, what guys? Okay, so when you think of someone being very sentimental, you think of them being very emotional. Try to put those two together in your mind when you're talking about, or when you're trying to remember terms. Okay? Give me 1 second. I don't know why you're matching, but all right. Okay. Who? Okay. Who wrote? Give me one moment. Who wrote the bells? Who wrote the bells? Okay, well, you guys say it all together. Ready? Edgar Allan Poe. Candy for you. Candy for you. Did you say it? No. Okay. Did you say it? Did you say it? Anybody else over there say it? Okay. So Edgar Allan Poe wrote the bells. Give me the three kinds of bells mentioned within this story. Give me one. Give me one. Andrew? Silver bells. Okay. Who knows what this one represents? Huh? Do you know? No. Okay, everyone go ahead and turn back to the bells. All right, so when on our quiz, so remember these kinds of bells represented three life events. Okay, the silver bells. Okay, that is on page number, what was it, Avery? 155. Okay, silver bells. Okay. So look at, here are the sledges with the bells, silver bells. What a world of merriment their melody foretells, how they tinkle, tinkle, tinkle in the icy air of night, while the stars oversprinkle all the heavens of light. What was it, Amethyst? Christmas bells or silver bells. Okay, this, or sleigh bells, sorry. Christmas bells, sleigh bells. Those are the silver bells. Tinkle, tinkle, tinkle. Actually, what is that term used? Okay, we already talked about it, but that term used that kind of sound like what they mean. Onomatopoeia. So with tinkle, it kind of describes that whole sleigh bell thing when it's like tink, 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 tink. You know what I mean? Okay, so that's an example of onomatopoeia. Okay, what's a second kind of bell? Gabby? Golden bells. Who knows what this represents? Elijah? Wedding bells. Awesome. Okay. Hey, I made it on the table. Okay. Golden bells represent wedding bells, and we think of gold when someone has their golden anniversary or their golden birthday. That kind of represents endurance or strength. Okay. What's another type of bell? Amethyst, you have a question? Huh? Brazen bells. Okay. Oh, my soul. Okay, brazen bells. What kind of bells are these? Kind of like brass a little bit. Austin. Not funeral ones. What is it, Avery? Alarm bells. Okay, with this one, you can see like the brass is kind of like a harsh call to action. This is where we see cacophony, where it says, when the tale of terror now their turbulency tells, in the startled ear of night, how they scream out their affright. That is a use of cacophony, using harsh sounds to kind of emphasize a point. And then the last kind of bells that are mentioned here. Lena, you want to look? Page 157. No. Okay. Gabby, do you know? The iron bells, and those ones, Austin, represent what? Funeral bells. Okay? So, those are the three kinds of bells that are mentioned within the bells. But if you put what they mean, so like if you say golden bells, what they represent, silver bells and what they represent, I can give you extra credit for that. Okay? All right, next, let's see. Next questions. Who wrote God's Grandeur? God's Grandeur. Avery? Hopkins. Gerard Manley Hopkins. Okay? And what is the theme of God's grandeur? The theme of God's grandeur. That's the one where it talks about nature. What was it, Amethyst? God's greatness. Okay, that'll help you. Talking about God's grandeur or God's greatness, despite man's efforts, is never diminished. Okay? All right. Let's see. Who wrote The Destruction of Sennacherib? The Destruction of Sennacherib. We didn't discuss it that much, but we did read it. What was it? George Gordon, Lord Byron. Good. Okay. Okay. Who wrote What Men Live By? Jesse? Well, I want everyone to participate, Austin. I'll call on you. I've called on you several times already. Leo Tolstoy. Ready? Okay. Leo Tolstoy wrote What Men Live By in class. What do men live by? Love. Okay. Who wrote The Rainy Day? The Rainy Day. Avery? Longfellow. Okay. Who wrote The Servant? Who wrote The Servant? Maya? Okay. Semyonov. That one didn't fly as far. Okay, so Semyonov wrote The Servant. Within The Servant, who was the angel? Who was the angel? Andrew, Michael. Well, I called on you already a couple times, and you look at me like this. So, okay, who was the main character? Who was the main character? Simon. What was his occupation? Austin? Shoemaker. Shoe worker. A shoemaker. Not really. Shoemaker. Let's see. Why was Michael sent to Earth? Who remembers? Okay, Amethyst. Okay, but the general answer. Okay, you're giving the detailed answer. Good. So the answer to that in short would be to learn a lesson. Okay, God sent Michael to earth to learn a lesson, or God punished him because he didn't listen. Okay? Yes, Andrew. To see what men live by. Those are the lessons that he needed to learn anyway. Okay? Let's see. Who wrote The Frill? Who wrote The Frill? Gabby? Pearl S. Buck. Okay. Who was the really mean lady in the story? What was her name? Avery? Mrs. Lowe. Ugh, one of these days, I'm going to get it. Okay? Okay. Let's see. What is the greatest thing in the world? Lena? Love. Love is the greatest thing in the world. Okay. Who wrote After the Battle? Who wrote After the Battle? Avery? Hugo. Victor Hugo. Hey, that one was good. Okay. Victor Hugo wrote After the Battle. Who wrote Sympathy? Who wrote Sympathy? Okay. Do you know? Paul Lawrence Dunbar. That was left hand. That was left hand. Huh? This bag does. Okay, so yesterday we talked about what does the author, Paul Lawrence Dunbar, of Sympathy compare himself to in the poem? Who remembers? Good, a caged bird. That was close. Okay, a caged bird. All right, that's what he compares himself to, and obviously in the story he kind of puts himself in, or the poem, I should say, he puts himself in the bird's shoes. Okay, we're going to continue review for tomorrow. Make sure that you guys are studying for your test on Thursday. Tonight for homework, for vocab, write your words 7 through 12 2 times. No grammar homework. Okay? All right, you guys are dismissed.
Oh, DLs, good to see you again. Good. Camera's over here. Um, Mr. Coral is not here today. He's on that basketball tournament trip. So he just has an assignment for you to do today. That is to read pages 285 to 289. Read pages 285 to 289. And then on 293, answer questions 1 through 6. Okay? That's the only thing he has for you to do. Once again, it's read pages 285 to 289 and answer questions 1 through 6 on page 293. Okay? Text me if you didn't get that, or if you're not sure what's going on, and or text each other, whichever you need to do. And otherwise, I'll just sign off for you and let you get on to that. Okay? One more time. Read pages 285 to 289. Answer questions 1 through 6 on page 293. Okay? We'll see you later, DLs.
All right, testing 1, 2. Wow. All right. Welcome to geometry. Let's go ahead and get started. Right as I clicked the scene where I'm going live, then you do that. Thanks. Anyway, okay. We're on exercises 3.7. We're on number 14 because we did number 11 yesterday. Tonight's homework is number 8. Okay. I mentioned that yesterday, I think. I don't know. Yes, I did. And just as a reminder, number 8 has 5 steps according to the textbook. Has 5 steps. So just make sure that you guys do that tonight on there. And then, like I said, I'll be grading 3.1 to 3.8 homework on Friday. All right, so let's go and move on. We're going to finish up the proofs of 3.7. I don't know if I've mentioned it yet or not, but you guys have a quiz on Friday over 3.5 to 3.8. You guys also have a test coming up Monday, Tuesday of next week. Throwing that out there. 3.8 will be the last section before the test.
Why have all our tests been Monday, Tuesday?
Magic? Okay, moving on. Because I can't fit it in before, like, normally I would say, like, this week. I might have potentially given it Friday, but I'm not going to give a Friday, Monday test. You know what I mean?
Yeah.
So, like, that's why.
That's why everyone hates Mondays.
Yeah, well, who doesn't? All right, number 14. We're told to prove that if a chord is drawn parallel to a diameter, then the arcs intercepted between the chord and the diameter are equal. Okay? And then we are given a suggestion to draw radii to the ends of the chord. So, first of all, what's the first thing I should probably draw? The circle. Yeah. Circle might be a good idea. Oh, yeah. Real quick, if you guys are ever trying to draw on a computer and trying to make like a circle and not an oval, hold down Shift. Just pro tip. Cool. Let me see here. And then I need to create a line. Can I change the thing? Yeah. Okay. Well, let me keep it. No. Rip. All right. So I have a diameter. And then I'm going to have a chord. All right. And then they recommend, quote unquote, that I draw... Oh, goodness, where's the center of the circle? I hope there. Radii of the circle. We're going to assume that that is to the exact center of the circle. I honestly have no idea. All right, we will label this A, O, B. That's going to trigger me too much. Okay. And then we're going to have C and D. Although we're going to label it D on the side. Cool. There is our diagram. So we'll save and close this. Shrink it down so it's actually like reasonably sized. Maybe. Kind of. Alright, so this is the idea of what we're going to be working with. Let's go ahead and create our table. And number 1, let's go ahead and list our given. We have circle O. We have chord. Nope, sorry, excuse me. We have diameter. Help us if I'm reading the right proof. Diameter AB, and we have chord CD parallel to AB. All right, so that's our given, as shown in the diagram. Now, we were told as a hint, and so we went ahead and put it in our diagram, to draw OC and OD. So we can do that because 2 points determine a line. Yeah, we can do that. The book has it as step 4, but it doesn't matter. Honestly, I would have jumped to that too. So, what am I going to put as step 4? Yeah, because I would have definitely seen the equal way before this step. Okay, now, angle BOC is going to equal angle DCO. So this angle here will equal this angle. And there's going to be another one, but we'll get that one in. And then we have AOD equaling to CDO. So this angle to this angle, because alternate interior angles. Why are you like this? Okay. Honestly, I should have just probably jumped to step 5 as step 4 and then done this later, but we're moving on. Okay. Step 4 could be moved down to step 5 and this be placed. It doesn't matter, as long as you get it all said. We don't really need it all until step 7. So, because the radii are equal, notice that we have an isosceles triangle. So that makes... Yeah, I think that's why they did the angles first. Whoops. Again, I probably would have done this first. But it doesn't matter. Now, because I have an isosceles triangle, honestly, it's not necessary to say it's an isosceles triangle. Well, they're using it for the base angles are equal, but we can say that without saying that the triangle is isosceles. So, saving a step. Yeah, but we have an alternate form of it where we can just say sides opposite, or angles opposite equal sides in a triangle are equal. So we don't need to say that it's an isosceles triangle. I mean, it's not wrong. It's just not necessary. Yeah, basically. Okay, anyway, angle DCO equals angle CDO. Angles opposite equal sides in a triangle are equal. Okay, so because we have that, now notice that I have DCO equaling CDO, so notice that makes BOC equal to angle AOD by substitution, yep. Well, then if those angles are equal, BOC and AOD, what does that mean about their arcs? Arcs are equal. I have an extra line because I saved a step. Yeah, because it's not necessary. It's, again, it's not wrong. I mean, you could do it that way. It's just, why? That's also a much reduced version of the actual reason. Because the book says, if in the same circle two central angles are equal, then the arcs intercepted by them are equal. Which is, again, is fine, but again, less writing better. Alright, so there's that. Go through and add this to your proven statements. Go ahead and read the text out of the book so I can start setting up the next problem. We're on page 141. That was number 14. All you need to do is write everything after prove that, and then stop at where the suggestion begins. No. Oh, you've got to be kidding. Oh, rip.
How many steps was
It's not that it's the next proof. I forgot number 16 has 3 parts. So it has 3 proofs. While you're writing stuff in proven statements, go ahead and write number 16. This is all you need for number 16. But to prove it, we have to consider all 3 cases. Does that make sense? So the proof is long, what you're writing in your proven statements is not. Why can I not type today? Okay, that is coming off for now. This is an evil one to do and then not provide the diagrams. Oh yeah. That's the whole point of the 3 cases, is that there's 3 possibilities. One is that the 2 chords will actually intersect on the circle itself, like actually touching the circle for the point of intersection. One is where they'll be inside the circle somewhere. The one is where the point of the intersection is outside the circle. You'll see what I mean when I draw the diagrams. Man, I kind of wish I had them scanned right now. Alright, insert, drawing. I'm just going to create them because we got to go. So again, you guys are working on getting those 2 things in your proven statements. Oh, I'm holding caps lock, not shift. Minor details. But this is why I work with you guys. Huh? Yeah, number 16. While you guys are at it, do number 18 too. Because we're going to prove it today. Or we're going to assume proven today. One of the 2. Alright, and then, okay, I'm going to draw 2 lines just so I know where in the world the center of the circle is. Why I didn't do this in the first place, I don't know. Okay, shapes, circles. Alright, and then I missed. Yeah, that's what I wanted to do. I'm focusing too much time on that. Especially seeing as I have like 1 million of them. We're drawing this perpendicular, right? Yeah. of course, nothing is in a straight line right now. Cool. You guys see what I mean about this one being on the edge of the circle, though? Where it's actually on. So, oh goodness, I gotta do 2 more of these. Alright, well, we're gonna do the first proof while we're here, and then I'll make the next diagram. Alright, ready? Cool. Let's shrink that down to something more manageable. Alright, so when the 2 chords intersect on the circle, so we're to prove AB equals BC. That's the end goal. Okay? We're proving that the chords are equal because they're creating equal angles in this case. So, insert. So let's go through our given. Whoops, I can take off italics. There we go. Now it fits. All right, so we have our given here. Oh, rats. I forgot to take off italics before starting the table. Okay. I'm going to do myself a favor here. All right, so we have circle O. We have diameter BD. We have chords BA and BC, or AB and BC. It doesn't matter. And angle ABD, we're told, is equal to angle CBD. Okay? Now, with that, our end goal is to prove BA equal to BC. So first thing we're going to do is we're going to draw a couple of perpendicular lines. So we're going to draw OE perpendicular to AB, and then OF is perpendicular to BC. All right, because exactly one can be drawn to a line from a point outside the line, okay, or construction of perpendicular, doesn't really matter. Now, number 3. Yes. I could, but technically it's supposed to be its own step. If we do that, it's not necessary though. In this case. Let me see here. So if I have right angles, what do I have? Yep. No, we don't need to. Yep. All right, so first of all, let's see here. We have right triangles. Okay. I already know I have an angle. So that's fine. Let me see here. So if this is your right angle, right here, where's your hypotenuse? So OB, the radius, yes. Yeah, exactly. So that's the approach we're taking, though, because then we can use hypotenuse angle. So then my triangles are congruent. Yes, by Ha. Okay. Anyway. We already know the angles are equal. We can prove the sides equal. Okay. So OE then must equal OF. Oh, right. Now, remember, our entire goal is to prove BA. Notice that's not part of the triangle. We can't just say that side. So instead, what we're saying is we're saying the distances are equal. Well, if the distances are equal from the center, the chords are equal. So that allows us to jump to step 8, saying BA equals BC. Yeah. So that's the end goal. All right, makes sense? Cool, moving on to B. Oh my goodness. Why though? Okay. B, we're going to basically be taking the same approach, except we have to prove it when they're not on the circle. So first of all, let's insert our drawing. We're not going to get done today. I forgot there was 3 subproofs, otherwise I would have had the diagrams ready to go. That's not, wait, why did I grab, what? I'm confused now. Alright. So now, instead of them being on the circle, let's say they're inside the circle, because that's case B. So I'm going to draw a diameter first. Okay. And then sure, why not? Okay. Thanks, guys. Why did you all draw them as perpendicular? You can't do that. I'm okay. Try to make sure that we're equal, I guess. All right. All right. I have to make the same angle. Oh goodness, this is gonna be pain. I'm seeing why they drew them as perpendicular. Oh, nope. Fine. Sure, that looks like it'll be about the same distance. Never trust a diagram. Hey, now. Just because you're right. Stop it. You know, think never trust a bunny, it works. Okay. That angle is not the same. I missed the point of intersection. I'm spending way too much time on this. No, I don't want you jumping there. I want you going where I said to. Yeah, that works for me. Can we all agree that's close enough? Oh, rats, I still need to find the center of the circle. Do that. Do that. Okay, now insert a smaller circle. Delete that line, delete that line. Zoom to fit. Cool. And now I can label everything. Oh my goodness. Alright, is that even point A? Nope. Alright, so let's make this point A. Make this point B. Make this here point C. Point D. Point E. This shall be circle O. We'll call the point of intersection G. And then I need to draw perpendicular lines. Oh my goodness. Can you not, like, just interfere with my drawing? I mean what I say. That's perpendicular enough. Go with it. We'll call the 1 H, so many letters. And J. Alright, cool. There we go. Alright, so now for this one, we are assuming that the point of intersection is within the circle. Alright, you guys see what we're doing? Ladies, you guys see what we're doing? Okay. So let's go ahead and get into our table. Okay, we're going to go a little faster because, seriously, it's the same thing. We have circle O, diameter EF, chords AB and CD. Right, I can't have that space there. And then finally, we have angle DGF equal to angle BGF because of our given. Now, I've gone ahead and drawn some perpendicular lines, so let's just go ahead and declare that now. We're going to draw OH perpendicular, right, perpendicular to CD, and OJ perpendicular to AB. Because we have perpendicular lines. All right. Number 3 then, if I have perpendicular lines, what do I have? Right angles. So angle OHG equals, oh goodness, you know, I don't even care that I technically can't do it. We're saving time. Equals angle OJG, which is equal to a right angle. All right, if I have right angles, what do I have? All right. Can we all agree that OG equals itself? Cool. Then, using the same method we talked about last time, the triangles are congruent. If I have congruent triangles, that means I have congruent pieces. So the two I'm interested in this case are OH equals OJ by CPCTE. Because I've proven the distance is equal, then the two chords are equal. Yep. Yeah, it's basically the same proof, different letters, but you have to state it based on each case. Yeah, it's just different enough where it needs its own proof. So that's the idea here. We're going to finish off part C tomorrow because I'm out of time. And then we will also do number 18 tomorrow as well, and then we'll jump into 3.8. 3.8 is not a super long one, so I'm not super worried. And I already have 2 days for it, so we'll just spill over a little bit and get it done. All right, any questions? All right, again, tonight's homework is number 8, which again I think is 5 steps. Is that what I said? Yeah, 5 steps. According to the book does give you the diagram, so you guys have that at least. They also just straight up give you a given and prove statement, so it should be relatively straightforward. Hopefully, give that your best shot and submit that, and I'll see you guys later.
Dales, can you hear me now? Sorry, guys. Hopefully you're watching the screen as we went through this. Sorry about that. I've been having to, I've been subbing for classes today, and so I've been turning on and off my mic, and so I forgot. So apologize. Next question. That's circuit breaker, okay? Shh, ladies, come on. Okay, long one here. What is the situation that occurs when too many appliances or electrical devices are connected to a circuit at one time, forcing the wires of the circuit to carry more current than they can safely handle? It's called an overload. Okay. Now, yesterday we briefly talked about this, but today I'm going to get into more of it, the specifics. There's two ways that a circuit with more than one load, okay, can be arranged. Those are in, ladies, those are in a series and in a parallel, okay? Now, so, first of all, let's talk about the series circuit. A series circuit is just a type of circuit where the loads are arranged so that electricity has to flow through each load one after another. Okay? This is where you would get your Christmas lights situation. Okay? So it makes the train track around. The electricity starts at the depot, the battery, the load, goes through, or the source, not the load, goes around the track, goes around the first curb, makes its first pit stop at the first light, okay, picks up its passengers, goes on to the next stop, next light, picks up its passengers, goes on to the next one, the third one, and then it goes back to the depot, okay? That's a series circuit. It must pass through each load to get to the next one. Okay? There's no bypass. If one light bulb in the figure burns out, all the bulbs will stop burning. Just like your Christmas lights. Okay? Shh. Guys, ladies. In a series, the resistance of the individual loads add to each other. Okay? So therefore, because the current must pass through each resistance to get to the next one, you have this equation going on. Resistance total equals resistance of the first plus the resistance of the second load plus the resistance of the third load, and however many loads there are, you just keep adding them on. Okay? That's getting a total resistance off of a series. The current must be the same in all parts of the series. Okay? Pit stop number one, load number one, has to have the same amount as load two, or load two has to have the same amount as one. Load three has to have the same amount as load one. Okay? So there has to be the same amount of resistance or circuit current going through each load. Amethyst, please have a seat and stay there. Austin? Yes. Now, in this, we got the Ohm's law that fits into this. All the Ohm's law got to be obeyed by both the entire circuit and any part of the circuit. Okay? So the total voltage of a series circuit must equal the sum of the load's individual volume. Okay? Amethyst and Avery, you got one. So you got your voltage total equals the resistance total over your load total equals your resistance of 1 over your load total plus the resistance of the second with the load total, resistance of the third over the load total, plus, and you just keep adding on all the loads, will give you your total voltage for the series. Ladies, enough is enough, okay? So, looking at this example, it's a long one. Follow along in your books or your paper, your notes. For the circuit in figure 9.23, a series circuit, calculate the total resistance, the total current, and the current through each light bulb, and the voltage in each bulb if the battery has a voltage of 6 volts. And each bulb has a resistance of 12 ohms. So we got to first figure the total resistance. And we do it by this equation. Resistance total equals resistance of the first load, the second load, third load. Or, putting the numbers in there, 12 ohms plus 12 ohms plus 12 ohms gives you a resistance total of 36 ohms. Okay? That's the simple part of this. Then the current through each bulb equals the current through the entire circuit. So the total voltage equals the voltage of the battery. Knowing that allows calculating the current using the Ohm's law. Okay? So the load total equals voltage total over resistance total. So you've got your 6.0 volts divided by your ohms or your resistance total, 36 ohms, gives you a 0.16674 or about a 0.174. Okay? Then, the voltage in each bulb can be calculated using the Ohm's law with the resistance and the current of each bulb. So since the current and resistance are the same for each bulb, the voltage must be the same in all bulbs. Volt 1 equals volt 2 equals volt 3, giving you is that an I or an L? Am I saying it wrong? IT over times resistance total, or giving you 0.1667 amps times your 12 ohms, giving you a volt of 2.0004 or 2.0. So, with doing all this, we have the 4 answers. Total resistance, 36 ohms. The current through each bulb is 17 amps, or 0.17. Our total current is 0.17 because each load has to have the same amount of amps. And therefore our voltage for each bulb is 2.0. Okay? So just some important facts to remember about a series circuit. The Ohm law applies to any series circuit or any part of a series circuit. The total resistance of a series circuit equals the sum of the resistance of the individual resistors, or the loads. The current is the same in all parts of a series circuit. And number 4, the total voltage of a series circuit equals the sum of the individual voltages. The voltage is divided among the loads. Okay? Our second type is the parallel. These are loads that arrange in separate branches of the circuit, and the current is divided among them. Okay? This is page 16 of your notes. Now, so the current does not have to flow through each load to get to the next. Shh. Ladies, rather it flows through all the loads simultaneously. Okay? You can look in your books, figure 9.24, page 232 of that, but it's just basically like what we see on the picture. If several light bulbs are wired in a parallel and one blows out, the rest will still continue. There are some Christmas lights out there that are made in this way. If one bulb goes out, the whole thing doesn't go out. Okay, these are nice because then you know exactly which one to replace. Otherwise, the series you have to go through and make sure each one is good to use. So because the current in each branch has more than one way to get through the circuit, the total resistance is reduced as loads are added in parallel to the circuit. Okay? Get that? The total resistance is reduced. So, the reciprocal of the total resistance is the sum of the reciprocals of the resistance of the individual loads. Shh. You got this equation. 1 per resistance total equals 1 of resistance of the first load, the second load, and the third load. Adding them together gives you your 1 to the resistance total. So the voltage in each branch must be the same as the voltage of the circuit of the whole. Otherwise, the voltage difference would cause circuits to flow through one load backwards. And so we know that electrons always move from low voltage to a high voltage. They don't move backwards. So since the total resistance of the circuit decreases, the total circuit flowing through the circuit increases as branches are added. But the current flowing through each load remains the same because the voltage and the resistance do not change. So, if we add another bulb to the parallel circuit, the other bulbs will keep their brightness as long as the power source can meet the increased demand of the circuit. Okay? So the voltage, the amps do not go down unless the source can't hold the loads. Okay? So these are important. These are the important facts of the parallel circuit. Ohm's law applies to the parallel circuit or any other part of it. The reciprocal of the total resistance of the parallel equals the sum of the reciprocals of the resistance of the individuals. The voltage is the same in all branches of the parallel, and the total current of the parallel equals the sum of the individual currents. And therefore the current is divided among the loads. Okay? So, your example, 9.2. For the circuit in figure 9.24, parallel circuit, calculate the total resistance, the total current, the current through each light bulb, and the voltage in each bulb if the battery has a voltage of 6.0 volts and each bulb has a resistance of 12 ohms. So first of all, the total resistance is taking all of those, just adding them together. Okay? Then you've got to do the reciprocals of those. Okay? And so your R total equals 1 ohm per 0.2499, or giving you 4.002 ohms equals 4.00. The voltage in each bulb equals the voltage of the entire circuit. This is known because the voltage of the battery, so voltage total is voltage 1 equals voltage 2, voltage 3, or total of 6.0 volts. So the current through each bulb can be calculated using the Ohm's law. So since the voltage and the resistance are the same for each bulb, the current will be the same in all the bulbs. Okay? And you have your equations right there for that. The total current is the sum of the current through each bulb. Okay? So if one bulb is whatever amps, the other one has to be the same. And so the total current is the amp or the voltage that's going through each one. Okay? So we have these four things. In example 9.2, total resistance is 4.00 ohms. The total current is 1.50 amps. The current through each bulb is 0.50 amps. And the voltage in each bulb is 6.0 volts. Okay? So let's put this to practice. So that puts us on page 17. 4 light bulbs with a resistance of 24 ohm or 240 ohms. Each are connected in a series to house current 120 volts. What is the total resistance of the current or the circuit? The total current, the current through each light bulb, and the voltage in each bulb. Here you go. The total resistance comes up to 960 ohms because you're adding 240 4 times, okay? Or quicker math, taking 240 times 4. For the current, the total current. Are you on the first section, second, or third? What you talking about? Well, you have to find out one to get to the other. Yeah. So the resistance is 960 ohms. Okay? So that's the resistance of the circuit. That's the first question. The total circuit is the second group. IT equals VT over RT. 120 volts divided by your 960 ohms, the resistance, giving you for your total current comes out to 0.13 amps. Okay? Then the current through each light bulb and the voltage in each bulb is the voltage section down there. V1 equals V2, V3, V4, or coming up with 30 volts for the whole thing. Give you a moment to write all that down. Get better. Okay, still waiting on a few here in the class, guys. So, okay, anybody in the class? Hey, ladies, anybody in the class still working, doing this? Okay, I just. She wasn't here yesterday. Okay, done? Okay, DLs, here we go. Number 2. Shh. 10 Christmas light bulbs, each with a resistance of 17.1 kiloohms, are connected to a parallel circuit to 120 volt household current. So what's the total resistance of the circuit? The total current, the current through each bulb, and the voltage in each bulb. Here you go. Shh. Ladies, please talk later. You got a lot of writing to do. So keep in mind that the resistance in a parallel has to be equal, the total has to be equal to each one. Okay? So therefore, the total of each resistance or each load is 17.1 kiloohms. Okay? So your total resistance is 1.710 ohms because you're dividing it by 10, the amount of the loads. Your total current comes out to 70.717563, okay, divided by 1,000, or 0.070 ohms. Your current flow, the total current or the current through each bulb, is IT equals VT over resistance 1, or the load, resistance total, excuse me. So 120 volts divided by 1.170 ohms gives you for that 40.1756386 ohms. And then each bulb, the voltage for each bulb comes out to 0.0070 amps with a total voltage of 120 volts through the whole thing. That's your source. So since you plug the whole parallel set of lights into a 120 volt, the 120 volts is going through the whole parallel series. Okay. Why there's so much in the first section is just showing you each of the loads. Each load is the 10 Christmas light bulbs. Okay? Obviously there are some shorter cuts to do this, but I'm putting it out here so that you see exactly what the problem is talking about. And the values of each. So if you take 17.1 plus 17.1 times 17.1, or multiply 17.1 times 10, you get your 1.710 ohms. You could multiply them. Well, if you take the initial 17.1 ohms and divide it by your 10, then you get the amount of ohms for the total resistance. Yeah. I think what we'll do, okay, everybody in here got this down? Yes. The total current, the resistance, the total current is your where are you at? Come here real quick. This right here? Total current. Oh, because of your kilo. That's where the 1,000 comes in. Okay. And the 70.175 is basically this times, I think, times 10. Okay. This is what my book gave me, that number 70.1756386. That's still in kilos. So we take that divided by 10 to get rid of the kilos to get just our ohms. Okay? So that's our total current.
Okay. Then what do we do with the 40?
That is our current through each bulb.
Oh.
Yeah. Okay. DLs, here's what I'm going to do. I probably have, ladies, shh. I have boggled your mind quite a bit on this practice, and we still have 2 to go. So here's what I'm going to do. I'm going to pick up the last 2 practice problems tomorrow. After we do those, then we'll start on chapter 10, or chapter 10 notes. Okay. So cutting a little bit early today, just a little bit, 5 minutes, but rest your mind. Start thinking about how long of a Christmas light pattern you want to have next year, whether you want to go series or whether you want to go parallel. And ask yourself, does blinking lights add more to it? We'll see you tomorrow.
All right, welcome to Algebra 1. Please remember to, oh, you know what? I should have had that slide up. Okay, you know what? I'll do that at the end. All right, if you haven't already gotten your new worksheet, make sure you get it off Google Classroom. But we're going to do the first problem in each section to talk about how each problem should look by the time you're done, as well as what the answer should be. Number 1 here, we're told to solve each system by graphing, so we're going to do number 1 together. If you do not have a ruler, I highly recommend grabbing one real fast. Okay. Now we can graph using any different method, but notice that these problems are already in slope-intercept form. So I'm going to pick that method because it's already there, and you all are killing my computer. It's all good. I'm just... Screen went dark. It's really okay. I'll let you guys have a seat first. So I'm going to do the top one in blue, the bottom one in green, so it's obvious which line is which. Okay. This was like the easiest thing I could have said today. I'm telling you I'm doing that for demonstration purposes. Oh my word. Okay. So remember with slope-intercept form, the number at the end is where you start. So I'm starting at +4, so I'll go ahead and mark that with a dot. And then the number before the x is your slope. So that -3 is -3 over 1. So I'm going to go down 3, 1, 2, 3, to the right 1. If I can hit the line. And then if I want another point, 1, 2, 3, to the right 1. And then I just connect the dots. I mean, what? You're connecting dots, man. This is from kindergarten. Guys, do I really have to give you all another worksheet on slope? We've gone back and talked about slope a billion times. No. Just, yeah. So what is the definition of slope? Rise over run. So that means slope has to be a fraction when you go to put it into place. If you have a whole number, what do you put it over? 1. That's it. I didn't do any. There was no math to be done. I put -3 over 1, so that way it was a fraction. Okay, rise means how far up and down you're going. If it's negative, you go down. Okay, run means how far across you're going.
Why didn't you do that before?
I did. What are you talking about with 4? 4 is where you start. Guys, we went back and did separate worksheets on this section too. Please remember something from one day to the next.
Oh my God, you're great. You look like you're gonna have a mental breakdown.
What do you mean gonna? Okay. All right, seriously. No, I actually don't understand. Okay? This is like basic concept here, guys. Okay? But I've been graphing like this for the last 3 chapters. That's not my fault. Okay. Here we go. Now, we're starting at -2, right? Because that's what we do. Okay? So I'm at -2. That's where I'm starting. Oh, my word. No. Okay? Now, if my slope is 3, that means I have 3 over 1. So that means I'm going to go up 3, 1, 2, 3 over 1. So I'm going to go through here, go up 1, 2, 3 over 1, and I'm going to put a mark here. And then we connect the dots. Now, this point of intersection right here, oh my word. Grab the pen. There we go. This point of intersection right here is my answer. I need to specify the answer, but that is the answer. What? What is there a question on? I actually don't understand.
He's literally just talking about what he never say. I did this, and I must have done this in the class.
Y equals mx plus b.
Well, I know that. But,
B is where you start
okay, but
on the y-axis.
I'm not trying to. So,
M is how far up and down or left and right you go. It's always given as a
I
fraction.
said wait because I was confused because
What are you talking about, 2, 2? Nowhere did I label a point 2, 2. Ever. At negative 2, we start at negative 2 on the y-axis.
That blue one, or purple, whatever that color that is.
What are you talking about?
It's right there.
On the blue line, we started at positive 4.
Yes. You go down to where your second point is. That's negative 2, right? Where that thing is. On that.
That's my third point, but yeah.
That's how. Yeah. That's on negative 2.
What does it matter? That point has nothing to do with anything.
Because I put it on the graph and it's not lining up with anything.
Again, what are you talking about? Hey, if you're not in this class, zip it.
Sorry.
I'm having a hard enough time over here.
The whole blue line.
What are you talking about the whole blue line?
Okay.
You start at 4.
Yes.
You go down 3, right 1, put a point.
I just plotted it where you plotted it.
Austin, are you even listening to the words coming out of my mouth? You start at 4.
Yes.
Go down. 1, 2, 3, right 1. There's your next point. Then you connect the dots. This point is just an extra point so I could find the line easier. I went down 1, 2, 3 over 1. That 2, negative 2 has nothing to do with anything other than it's an extra point so I could line up my line better.
Oh my goodness, you're just like, I give you my. He quit.
Do we get it? Is it fine? Oh, Lord. I'm sorry. It's just habit to look that far over. Okay. So, now let's read this point. What is this point? Thank you. That's your answer. This actually hurts my head. Okay.
Is it a bad thing that I still don't understand it?
You're not in this class. I don't care.
Hey.
Why is nothing on the screen showing up? Oh my goodness. I love it when... No, like it showed my screen at the beginning, but then once I started writing, it completely stopped updating. So it was just a blank graph on screen the whole time. So that's what it should look like. Hopefully you all picked it up from what I was talking about. All right. I mean, honestly, the highest grades in this class are the distance learners. So,
Yeah, they cheat.
or maybe because they don't have everyone talking over me so they can actually hear what I'm saying.
Yeah, it's actually helpful when there's not a lot of people talking.
Yeah, weird how that works. Okay. So, let's move on. Austin, no one asked.
Don't use my own thing again.
Watch me. All right, on to number 5. We're told to solve by substitution. You may need scratch paper for this worksheet. Deal with it. Get out scratch paper. Okay, if you don't have enough room. All right. And? Okay. All right, so number 5. We already have y solved for x minus 3, so I'm going to plug that. Wait. No, let's rearrange the bottom one so that x is by itself. So we're just going to add 3 to both sides. That's literally all I'm doing. Does everyone understand what I'm about to do?
Yeah.
I'm literally going to put plus 3 on both sides. So x equals y plus 3.
Yeah.
Oh, my word. Yes? Oh, yeah, that's fine. Okay. So now in this top one, I'm going to put that y is equal to 4 times... Why did my brain just break? Yeah, that's right. Y plus 3 minus 9. Now you'll notice then I have y on both sides of the equation. That's fine. Don't freak out. Now let's start out by just simplifying as much as possible. So y is equal to 4y plus 12 minus 9. We distributed the 4. Any questions so far? You just had a whole worksheet on this, so I hope not. Yes? If you do it on scratch paper, make sure it's clearly labeled and stapled. But yes, I do want to see your work. All right, now we do have 12 minus 9, so we can take care of that. Y is equal to 4y plus 3. Now, I want to get rid of y on one side or the other. Okay? So, first thing we're going to do is we're going to subtract y from both sides. I don't know why part of my letter just disappeared and my screen just froze. Okay. You're stepping on the cord. Can you? Yep. Thank you. That's what's going on. And that's why my screen froze, probably. That's okay. Yep, basically. All right. So we're subtracting y from both sides. If I take y minus y, what do I have left? 0. Thank you. Whoops. 4y minus y is 3y plus 3. Now, I need to get y by itself. So let's subtract 3 from both sides. So then 3y is equal to negative 3. How do I get rid of that 3 in front of the y? Divide by 3. So then what does y equal? Y equals negative 1. Now, we're going to plug that back in for y in this equation. So x equals negative 1 plus 3, which is 2. Good. So to put our answer, we put x, then y. So far, so good? Cool. Let's move on to elimination. Oh my goodness. Huh? We're not getting into that. That's a lie. They just don't matter. Okay. Yeah, that's what I wanted to do. I grabbed the zoom tool because I wanted to write on my screen. Yep, that made sense. Because this literally... And my mouse stopped working. Cool. Solving it by elimination. I actually need to zoom out one notch because that's too much. All right, I need room to work. All right, so number 15. Here's hoping this still works. Okay, good. So by elimination means we're getting rid of x or y. Which one do you guys want to get rid of?
Y.
Thank goodness you all said x. Okay. Because notice that the top one, silence, the top one is just needs to be multiplied by 2 to get them to match. Again, it's not always 2. It just happens to be in this case. All right, so 8x times 2. Oh, yeah, that's right. I want to move this more to the left. Where's my... stupid mouse. Do the numbers match?
Yes. No.
That's my point. That's why I don't know what in the world Austin's talking about. All right. Okay, do the numbers in front of x match? How many times does 8 go into 16? 2. That's it. You're trying to get the numbers to match. You do that doing whatever multiplication you need to. But you have to multiply everything so you don't accidentally change an equation.
So if that actually is equal up there, I need to multiply.
What? Seriously, what?
So whatever number is in parentheses is how many times that number goes into.
That's how many times I'm multiplying everything in the equation by. So 8x times 2 is 16x.
Yeah, and that's the only thing that matters.
2 times negative 6y is negative 12y. You have to multiply everything, or it doesn't work. 2 times negative 20 is negative 40. The bottom equation can literally just be copied because it's already set up for elimination. Negative 16x plus 7y is equal to 30. Now then, we will go through and add these two equations together. What is 16x minus 16x? 0, thank goodness. Negative 12y plus 7y is? Negative 5y. Negative 40 plus 30 is? Negative 10. How do I get rid of that negative 5? We're going to divide both sides by negative 5, making y equal to what? Positive 2. Okay, then you pick an equation. Doesn't matter which one. You guys want to do top or bottom? Bottom it is. So we have negative 16x plus 7 times y, which we found out is 2, equals 30. Negative 16x plus 14 then, that's 7 times 2, that's what I did there, is equal to 30. Now we're going to subtract 14 from both sides. What is 30 minus 14? So I have negative 16x equals 16. How do I get rid of the negative 16 at the front? It's divide. So we shall divide by negative 16. In that case, x is equal to? Yes, that should be a division bar, by the way. Negative 1. So our final answer is 2, negative 1. Nope. Negative 1, 2. Yeah, I know. I got mixed up. X goes first, then Y. I accidentally wrote the first answer we got first. Okay. Those are the 3 types of problems. Again, I'm going to say this one more time. Number 25 is bonus. I'm not going to help with it. I'm not going to give hints for it. If you want to give it a shot, you may. I don't care. I'm more worried about the other 3 because... Yeah, it's extra credit. Bonus, extra credit, same thing. All right, so that is extra credit. But the reason I am giving this worksheet as an overall review of 5.1 to 5.3 is because you guys have quiz 16 over 5.2 to 5.3. I have rewritten the quiz, but it is the same directions. So if you look at your last quiz 16, should kind of give you a heads up on what it's doing. I did not change it by much. To be clear, every problem has a different answer. That is as much as I will tell you. So it will look very similar. You do need to redo the math. They are all different answers. All right? Does that make sense? Okay. I have rewritten it. Okay. I've manipulated each problem so that they give different answers. Let's put it that way. Same. Yeah, basically. They're going to look a little different, but if it feels familiar, that's a false feeling. Ignore that. That's just because I plagiarized like crazy. All right. I mean, kind of. In the sense that I'm telling you now. I'm not presenting it as my own work. All right, so we're good. All right, so that's what you guys are doing. This worksheet, worksheet 5E, I don't know why I named them that way other than I needed to fit it in the gradebook header. But this worksheet titled Systems of Two Equations is due tomorrow. Your worksheets 5C and 5D are due today. If you have not yet turned them in, they need to be turned in this calendar day. If you receive it returned as a 0, resubmit it. Okay? But that's just me filling in my gradebook so that there's no blanks because blanks irritate the fire out of me. Okay? So there's that. I do check for resubmissions every once in a while. So get that in as fast as possible. Quiz 16 is tomorrow. As such, there will be no lecture. And then we'll pick up back with the textbook in 5.4 on Thursday. Okay? Are there any questions? Oh, my word. Distance learners, I'll see you guys later.